Welcome to ATM Unit 2 review. This video will cover number 20 through 23. Your test is scheduled for this week. Number 20 says, a game show host says that he has $5,000 in $50 bills and $100 bills, and he will give you the $5,000 if you can tell him how many of each type of bill he has. He gives you a hint that he has 73 bills. Use an inverse matrix to find how many of each he has. So before you can even write the matrix, you need to write out your equations, okay? This is a linear. My bills, $50 bills, I'm going to call X. My $100 bills, I'm going to call Y. So, let's write our equation first. It tells you he has $50 bills, plus he also has $100 bills, and they total $5,000, okay? He also says he has $50 bills, we're calling X, and $100 bills, we're calling Y, and he has 73 of those bills. So before you start, let's go ahead and write this in matrix form. First of all, you're going to have your coefficient matrix. Your coefficient matrix will be made up of 50, 100, 1, and 1. Next, you're going to have your variable matrix. Your variables are made up of X and Y, okay? Equal your constant matrix. And your constant matrix is 5,073. Now, notice how I have all my X's lined up, all your Y's lined up, all your equals lined up, as well as your constant. And there you have your matrix. For you to solve, what you need to do is, as if you were doing anything, you would use an inverse matrix, okay? So, you're going to take this one and you're going to find the inverse. Now you can do all this on your calculator if you like, and the inverse button is a -1, okay? And what happens is you're going to multiply times this, and that's going to cancel out, and that's going to leave you your X. You're going to multiply it times your constant matrix, and there's your constant matrix. That is going to give you your X and your Y. Basically, this is all you need to set up to solve for your X and Y. But let me tell you what happens actually right here, okay? You had your matrix right here, your coefficient matrix, times your inverse matrix, okay, which is 50, 1, 100, and 1. They cancel out. And what you do is, what you do to one side, you do to the other side. That is actually what's taking place here. So now you can multiply this times your constant matrix, and that'll give you your X and your Y. Alright, so here I'm just going to type into my calculator. Notice I have a 2x2 and a 2x1, so I can actually use alpha zoom. Okay, so I have a 2x2, okay, and I'm going to type in 50, right click, 100, right click, 1, right click, 1. I'm taking the inverse of that, times your constant matrix, alpha zoom, 2 and 1, 5,000, and 73, okay? And guess what I have? 46 and 27. So, XY is equal to 46 and 27. Now let's take a look. Our problem says X is your $50 bills. So you have 46 $50 bills, and then you have 27 $100 bills. And that's your solution. Make sure you identify when you are doing application. And there's your number 20. Okay. Number 21. It says right here that Kara compares 3 fruits and nut gift packs. Write the matrix and solve to find the cost per pound of the pears, pecans, and nectarines. I'm going to call my pears X, pecans Y, and nectarine Z. Okay? This one will require a little bit of rearranging. So let's take a look. You have a pound of pears, half a pound and a half of pears, plus half a pound, pound and a half of pecans, which is Y, plus 1.5 pounds of nectarines. And all that's going to cost $22.50. Okay. The favorite packs. So this one, I'm going to write it down here. Okay. You got 3 pounds of pears. Remember, pears is your X. Plus 3 pounds of nectarines. Nectarine is your Z. Plus 1.5 pounds of pecan. And all that is going to equal $39. Okay. Family pack. 3 pounds of pecans. Now remember, your pecans is your Y. So 3Y and pears, 3X, plus 4 pounds of nectarines, and that's going to be $51. So there you have your 3 equations with 3 variables. So for you to write your matrix equation, this is what it's going to look like. Okay? It says, write the matrix equation. Just kind of like you did up here, here's your matrix equation. So let's write our matrix equation. All right, so you're going to have 1.5, 1.5, 1.5, 22.50. Okay, let me erase that. All right, and then the other one is 3, 1.5, and 3. And then you have 3, 3, and 4 times your coefficient, your variable matrix, x, y, and z. All that is equal to your constant matrix, 22.50, 39.0, and 51.00. So there is your matrix equation. So let me label that. All right, equations. Okay, it says solve to find the cost. Well, to solve, in order to solve for matrix, you have to use the inverse. So I'm going to take this number, 1.5, 1.5, 1.5, 3, 1.5, 3, 3, 3, and 4. I'm going to take the inverse of that. I'm going to multiply times my coefficient matrix, okay? Actually, I'm going to multiply it times your constant matrix of 22.50, 39, and 51. And that is going to give me my x, y, and z, just like you did in the previous problem. So let's begin. Alpha zoom, it is a 3 by 3. Okay? Not every square matrix has an inverse. So 1.5, right click, 1.5, right click, 1.5, right click, 3, 1.5, 3, 3, 3, and 4. Okay? To the negative 1 times your constant matrix, alpha zoom, it's a 3 by 1. So, okay, 22.5, 39, and 51. And that'll give you the price, which is 5, 4, and 3. All right, so your x is equal to 5, your y is equal to 4, and your z is equal to 6. And the question says, find the cost per pound. So it costs $5 for 1 pound of my X's pears, okay, $4 for pecans, and $6 for your nectarines, and all of these are per pound. And so there you have 20 and 21. That's your matrix equation. There's how you solve it, and there's your solution. Same thing, right here is your matrix equation. That's how you solve it, and here's your solution. Okay. Number 22 says, what is the identity matrix for addition? Now I want you guys to think about addition. Say for example, you add anything to 0, what do you get? Itself. Say you have x plus 0, that's x. 4 plus 0, that's 4. So anything plus 0 is itself. So let's create an example showing why it is the identity matrix, okay? So for example, I'm going to pick some easy numbers. Say I have 1, 2, 3, 4, 5, and 6. If I would have added every one of these numbers to 0, guess what you're going to get? The same solutions. Just make sure your dimension is the same, okay? The dimension has to be the same. Same dimension. And there's your addition matrix. Multiplication matrix. Well, what does it mean when you are multiplying? That means anything times 1 is itself. X times 1, sorry, that should be x times 1 is x. 4 times 1 is 4. Negative 4 times 1 is negative 4. See how everything times itself is that number. Let me rewrite this one so it doesn't look like a negative, okay? So, for example, say you have 1, 2, 3, 4, 5, and 6. Okay? Hang on just a moment. Let's take this one. If you were to multiply this times 1, 0, 0, 1, this is the identity matrix for multiplication. Okay? Whereas this one's identity matrix for addition. Let's see what happens. Here we go. First row, first column. Okay? 1 times 1 plus 2 times 0. First row, second column. 1 times 0 plus 2 times 1. See it? Okay? Second row, first column. 3 times 1 plus 4 times 0. Second row, second column. 3 times 0 plus 4 times 1. Alright? Now, if I were to do the math, guess what you have? 1 plus 0 is 1. 1 times 0 is 0. 2 times 1 is 2. 3 times 1 is 3. Plus 0 is 3. 3 times 0 is 4. 4 times 1 is 4. Okay. So, do you guys see how your matrix did not change? In addition, notice it did not change. So this is your identity matrix for addition, and here's your identity matrix for your multiplication. And you cannot divide in division. And good luck on your test. That is the end of your review.